Hello there. Welcome to the summary of lesson 6.3. We just, or I guess this is 6.4. We just, in this class, covered special right triangles in depth. We had learned about them in the last class, sort of investigated these relationships. And then in this class, we just practiced it a bunch. So to remind you, in an isosceles right triangle, which is also called a 45-45-90, two sides are the same. And then the third side, which in this case is the hypotenuse, is whatever this length is, it's that same thing times the square root of 2. So if this length is 8, then this length is 8 times the square root of 2. And, obviously, if this is 13, then this is 13 times the square root of 2, and so on. And this would also be 13, right? The one on the left here. So these two are identical. And then this one is, take that number and multiply it by the square root of 2. And so we said, okay, well, can we just do the basics of a special right or of a 45-45-90? If I told you that this side is 17, I think that corresponds to one of the legs. The two legs come together to make a right angle. And that would make this side 17. And then I said, well, what's y? And it turns out y is 17 root 2, right? Because it's just that 17 times the square root of 2. And then we looked at 30, 60, 90 triangles, and we said, okay, let's look at these relationships. And these are a little different. So here I'm saying the short side is kind of x, and the long side, the hypotenuse, is 2x. Because remember, this is half of an equilateral triangle. And so that means that this side here, whatever the length, you cut it in half to find the length of this side here. And so in our case, it was 26. And so that makes this side 13. And once you know that side, the short side, the 13 here, because it's half of 26, then finding the medium side, the side that's opposite of the 60-degree angle, is the length of the short side, but then times the square root of 3. So since I know that this is 13, that means that I can conclude that z is 13 times the square root of 3. All right, so you have, in a 45-45-90, you have the square root of 2 as one of your answers, and in a 30-60-90, it's the square root of 3. So that was sort of the basic problems that we covered. And then we looked at some slightly more complex ones. So here in each of these problems, I said, all right, I took a 45-45-90 and a 30-60-90, and I butted them up against each other so that they have a shared side. And I said, okay, everybody take a couple minutes and see if you can figure out the length of y, but you have to work your way through the triangle. So you might want to pause the video right now, look at this, and see if you can say, well, if the hypotenuse of this 45-45-90 is 21 root 2, what's the length of the hypotenuse of the 30-60-90? So pause, see if you can figure it out. And now I'll tell you, right? Because in a 45-45-90, these two sides are the same, and the hypotenuse is that length times the square root of 2. Well, this is 21 root 2, which means each of these two sides is 21. And then I can go down here and say, well, that's the short side. The side that's opposite of the 30-degree angle is 21 in my 30-60-90, which would make this side 21 root 3, and then I would double it to find y. And so y was 42, and that was what I was looking for. And you might want to try this one here on your own. There's the shared side. And then I'll tell you the solutions. Okay, so now we're starting with the 30-60-90, and that 88 is the hypotenuse, which makes the 2x side. So the x side, the one here, the short side, is going to be half of that, or 44. And this one would be 44 root 3, although that we didn't ask for that. Now in our 45-45-90, as we know, the two sides are identical, the two legs, and so this is also 44, but the one that we were looking for, z, that's 44 times the square root of 2. So we had to go through that logic there. And then we did one more set where we said, all right, now we've got a rectangle and a triangle. I said, find the areas. So let's think about this triangle first. If I've told you here that the length of the hypotenuse is 6 times the square root of 2, and the hypotenuse, again, that's x times the square root of 2, so that makes x 6, right? So this side is 6, and this side is 6. And it turns out we can count those as the base and the height of the triangle. So if we wanted to find the area, we could just do 1/2 times 6 times 6. So we had to use this length here to find the base and the height, and then we chug this through, right? 36 divided by 2 is 18 square units. And the other one is a little different. It's a little weird. It's a rectangle. So we would need to know the base, and we would need to know the height of the rectangle. But because it's actually two 30, 60, 90 triangles, one on top of the other, we can figure that out just given this diagonal here. That is the 2x side. The hypotenuse is 24, which would make the short side half of that, or 12. And so that means that the height of the triangle, or of the rectangle rather, is 12. And then the other side, the medium side, is that number times the square root of 3, so 12 root 3. And so I know that we could say that the base of the triangle is 12 times the square root of 3, and the height is 12. And so if I want to find the area, it's the base times the height, or 12 times 12 root 3. And this just means 12 times the square root of 3, which we're just going to call that 144. That's 12 times 12 times the square root of 3. And you could use a calculator to approximate that if you wanted to. But that's the basics. I said leave answer in radical form. So the area is 144 root 3. So I would take these practice problems and try the Kahoot that I've posted a link to. And then I'll also post an answer key to the Kahoot so you can try to learn from that. And once you've done all of that, you should do the exit ticket that I created, which will also be posted to show me if you can do these things or not.